Okay, here's some problems from section 6.2, and this is number 53, and these are just definite integrals and using a u substitution. So if we look at 53, we have the integral from 0 to 3 of y plus, the square root of y plus 1. So I'll write this as exponential form, y plus 1 to the 1/2, so I can use the reverse of the power rule. You know, add 1 or use u to the n du is going to be u to the n plus 1 divided by n plus 1. So what's my u going to be? Well, let my u be y plus 1, so I'll rewrite this as u to the 1/2 dy. But I need du. If I take the derivative of this, I get du equals dy, so that's nice, easy. There's a nice match. But I have to change my limits also, so remember, u equals y plus 1, so if this is 3, then I just add 1 to 3 and I get 4. And this is 0, u is going to be 0 plus 1, which is 1. So I'm going to integrate this from 0 to 1, and this becomes du. All right? Okay, hope you follow all that. So we change our limits, and we have it in the form of u to the n du. So it means I'm going to add 1 to 1/2. That's going to be 3/2 divided by 3/2 or times 2/3. I'm evaluating that from 1 to 4. And then we just use the fundamental theorem of calculus, f of b minus f of a. So 2/3, 4 to the 3/2 power, minus 2/3, 1 to the 3/2 power. Now the square root of 4 is 2, 2 cubed is 8, so that's going to be 2/3 of 8, minus, and then this is just going to be 1 to the 3/2, which is just 1. It's going to be minus 2/3. 2 times 8 is 16, so it's going to be 16/3 minus 2/3, which is 14/3. And you're done. Okay, and number 55. The tangent. Now right away when I see this, I know the derivative of the tangent is a secant, so I'm going to let it be u to the n du again. And my limits again are negative pi over 4 to 0, but that's in terms of x. So let's see. So if I let u equal the tangent of x, then du equals secant squared x dx, and there's my nice match right there. If I let tangent of x equal u, there's my u. Secant squared of x, but that's my du. I have to change my limits. If when u is 0, the tangent of 0 is 0, so I've got 0 up here, and when u is negative 1/4, the tangent of, negative pi over 4, pardon me. The tangent of negative pi over 4 is negative 1. Remember, it's in the fourth quadrant, and tangent is negative. So these limits go from negative pi over 4, 0 to negative 1 to 0 in terms of u. And this is u to the n, and then if I take the derivative of u over here, du is secant squared x dx, and I got a nice match here, secant squared x, so there's my du. So this is just going to be u squared over 2. That's the antiderivative of u, and that's evaluated from negative 1 to 0. So I use this, again, the fundamental theorem of calculus, f of b. So I'm going to put 0 in here, minus f of a, and I'll put 1 minus negative 1 squared. Negative 1 squared is 1 over 2 is 1/2. Minus 1/2, that's 0. Okay, so that was 55. Let's take a look at 57. That is 57. Okay, and then we have the integral from 0 to 1 of 10 square root of theta divided by 1 plus theta to the 3/2 power squared d theta. Well, if I look at this, I know the derivative of this is going to be 3/2 theta to the 1/2, and there's my theta to the 1/2, so I'm going to rewrite this. I'll put this up on top and make this exponent negative 2. It's going to be there, go from 0 to 1 of 1 plus theta to the 3/2 to the negative 2. Then I've got my 10 here, and I'll write this in exponential form. So it looks like I have u to the n du. That's what I'm working for. If I let u be 1 plus theta to the 3/2, then I've got u to the negative 2, and I don't know what my limits are going to be because I'm kind of mixed up here between u's and thetas. I brought the 10 out front, so it'd be kind of out of the way. And I've got this. So u to the negative 2, again, if u is this, theta to the 1/2 d theta. But I have to get u, so I have to get du, not d theta. So let's take the derivative of this. The derivative of 1 is 0. And the derivative of theta to the 3/2 is going to be 3/2 theta to the 1/2 d theta. Well, it looks like I've almost got that. I want to get a match here, so I'll multiply by 2 and divide by 3. And now I've got theta to the 1/2 d theta equals 2/3 du. So instead of writing this, I can write this. And then I can take the 2/3 out in front, so that'll make this 20/3. And then I'll just take the antiderivative of this and evaluate it from 1 to 2. So I add 1 to -2, I get -1 divided by -1. Now, how do I get my 1 to 2? Pardon me, I forgot to mention that. I have to change my limits. When u is 0, 0 plus 0 to the 3/2, I'm sorry, 1 plus 0 to 3/2 is just 1. So that becomes 1. And then when u is 1, 1 plus 1 to the 3/2, 1 to the 3/2 is 1, so it's 1 plus 1 is 2, so that just becomes 2. So that's how I get mine. I have to change my limits of integration. Okay? Got to do that over here. Okay, because we're using this formula for u to change our limits. It's real easy. U equals 1 plus theta to the 3/2, and I know what theta is. This is in terms of theta, so 0, 1. Put in there, and I get my u's. Okay? So again, I brought out the 2, so I had 20 and the thirds, 20/3. And then this is going to be antiderivative, so I add 1, divide by that. I think this is up here, so it's in good shape there. So that's going to be 20/3, and that's going to be minus 1/2. And this is the f of b minus f of a, so that's my negative from the f of b minus f of a minus. And this is going to be negative, and then 1/1. So 1/2, what's a negative times a negative of positive? So it's 1 minus 1/2, which is 1/2. So I end up with 20/3 times 1/2. This is all positive 1/2. 2 goes into 20 10 times, so it's 10/3. Okay? So that's 57. Hope those help.